Welcome to this final lecture on software architecture patterns. Today we're going to add authentication to our application. But before doing that, let's do a short recap of what we have learned so far. So we started by learning about software architecture patterns and specifically NTR architecture pattern. And we learned that NTR architecture pattern is a very common pattern and one of the most basic and popular patterns out there. And then we learned about three-layer architecture pattern, which is a variation of n-tier or n-layer architecture pattern. And this is a very simple yet convenient and effective pattern, especially for building web services and web applications. In this pattern, we divide our application in three layers. The most important layer would be the business layer, and that is the layer which we are trying to put most of the business logic to. So the essence of our application, the functionality of our application, what this application is actually doing, we try to put it all into this part. And doing this allows us first to reuse business logic of the application with different presentations. For example, we can provide the same logic using command line interface and REST API or whatever. And it also allows us to improve testability and maintainability of our application. Then there is a presentation layer, or we can call it a driving or input layer. This layer is responsible for exposing functionality of the business layer to the outside world. It can be exposing web UI for the user or command line interface for the user, or it can expose a REST API for another computer system to call it through. But essentially, it is a gateway or a way to interact with this application or to initiate the interaction with this application. And we aim not to put any business logic in this layer. Now, aim is the right word here because it's not always possible, as we're going to learn very soon, but still we try to do it. And then there is a driven, or we often call it a persistence layer. This layer is responsible for talking with the outside world, but in this case, our program, initiates the communication with the outside world and not the other way around. So the typical example would be talking to the database, talking to the web service, or talking to the file system where we initiate the communication. And again, we aim not to put any business logic in this layer. And that is basic description of three-layer architecture pattern. Going to the subject at hand, what is authentication? And in simple words, authentication is a process of verifying the identity of the user. We need to know who you are, who we are talking to, who is calling us, before we can do anything else. And what is authorization then? Authorization, as soon as we know who you are, as soon as we know your identity, we use authorization to check and enforce that you can use only the functionality we allow you to use in the way we allow you to do this. And it is not only important to understand the difference between authentication and authorization, it also is going to help us to structure our authentication and authorization related code properly and three-layer pattern. So where should we put the logic related to authentication and authorization? And that is a tricky question, but there are quite a few things we need to consider. So first of all, authentication and authorization are business logic. So we're going to have quite a lot of things done in the business layer. And in fact, most of the authorization, because those are business rules, will be likely to be done entirely in the business logic. Authentication, though, is not that simple. And that is because to authenticate, you need to provide some data through the presentation layer. You need to provide your password or token or whatever it is the way for you to authenticate. So there will be some part of the logic in the presentation layer anyway. And in the same time, quite often you need to either to speak with other authentication service or maybe with database. So you're going to have some logic related to authentication in the persistence layer too. But the very interesting way to approach authentication is to think of it like a separate API call, where you do nothing but authenticate. And if you think about it in this way, you can make a vertical slice of the logic which will be related only to authentication, which you can implement and test quite nicely. But we will see all of this in our demonstration, which we're going to do now. So let's start by planning our implementation. And we can break this in roughly 3 steps. Step number 1 is to add an authentication endpoint. Simply speaking, it's going to be an endpoint that takes username as a parameter, for example, username John, and then returns authorization token as a part of the user. As always, we're going to start with adding a test, which we did on the line 170, and it is named should provide authorization token for valid user. In the first step, we are creating a new user, and then we are trying to authenticate this user with the username. And what we are checking that the authenticated user is not none, so the service has returned something to us, and that the token is not none, and the other user data is also correct. If we're looking at the implementation for this functionality on the right, it is actually quite simple. We are getting username as an input data, then we are trying to find user in our storage. If user is not found, we return a not found exception. If user is found but authorization token is non-existent, then we generate a new token and we save the new token in the database. So the token would persist between different calls, at least for now. And then we return user. Currently, the generate token functionality is very simple. We just return in some random numbers, but you can always make it more complicated if you want. And let's see how it works in Postman. First of all, if I try to authenticate user which is not existent, I'm getting a user not found error with status 404, which is expected. And then if I first create a user and create with the some valid data, I get a response that the user was created, 200. It could be 201 because the entity was created, but again, RESTful API is not the focus of this particular course. And our token, as you see, is null, which means the user was never authenticated yet. And now we're going to authenticate the user. So we just provide in username and we get our authentication token. In real life, of course, username will not be sufficient for authentication. You will have to provide password or some other data to be able to successfully authenticate. And also, authentication token would likely to have some kind of expiration logic. For example, it can expire at a certain date, or it can expire after a certain number of usages. For the sake of the 3-layer course, this should be good enough. And let's try to see what's going on now 3 layers. We did not change anything at all on the persistence layer. We did most of the logic, creating the authentication in the business layer. We have updated our model. We have added auth token as a valid field. And we also had to update user controller and our main, where we essentially tie the controller to a particular endpoint. If we go to the main, we see that we have created a new endpoint authenticate, which gets incoming data, and then it is trying to authenticate using user controller. User controller, in this case, is not doing anything fairly difficult. It just gets the data from the username field of the incoming JSON, or at least tries to do so, and propagates this to the user service. And then, if user service works correctly, it replies with the dictionary. Now we are going to our second step, which is create user roles. As you remember, we have created roles data field in the user model, but we never use this properly until now. And for this demonstration, I'm suggesting to add three essential roles. First role would be the guest, which is basically any user which doesn't have a token. And guests will be able to create new users only. That will be the only thing that they are allowed to do. Then we will have administrator, and they should have unlimited access to all API and data. And finally, we will have a user. User is a guest which has created new user, and now they registered as a user in our system. And they will have read-only access to other users' data, and they also will have unlimited access to their own data, meaning that they can change and delete the data if they want. As we can see, it is actually fairly complicated business logic. So we understand that this part of authorization belongs to business layer. And that's how we're gonna implement this.
So we have agreed that we're going to have three roles: guest, administrator, and user. But how those roles are going to correlate to the user role value? And I'm suggesting to do it like this. We can agree that if we can't identify user, and then role is obviously none, then we treat this user as a guest. If user role equals admin, all uppercase, then it is administrator, and if user role equals regular, it is going to be user. Now it is time to do some coding. And first of all, let's have a look at the user service. In the user service, we understand that create does not care about token at all. Any user can create a new user. On the other hand, all other methods like get, update, delete, they will be requiring a token. So our first action would be to add token as a required parameter for all those methods. Token, if not provided, then none. It is not a required parameter, but it also will allow us to avoid unnecessary compilation errors when we are implementing functionality step by step. And in get, what we want to do now is to verify first that we have token at all. So that's going to be our first check. If token is none, then we raise exception, unauthorized, let's say. So instead of this exception, we going to create unauthorized exception. Raise unauthorized exception. Now we good. So if token is not provided, we unauthorizing. And which other cases we can treat user as unauthorized? So let's have a look at this again. So if token is not provided, we are complaining. Then we try to get the user for the token. If we can't find such a user, we complaining about the wrong token. And then if we can't find such a user, but this is not administrator, we still are not allowing to get this data. Obviously, this code is going to repeat for all other methods. And that is something that we will need to fix. But we will do this just in a bit. Right now, what we need to do, we need to create authenticate user method. So let's say authenticate user token. And then we need to go to the storage, and hopefully in our storage there is ability to find user by token, which there is not, but we're going to change this. Let's go to user storage. Here's our user storage. we need to add a new method. Find user by token, not implemented in this case, and we need to go to the SQLite storage, and in memory storage will be good too. So let's change in memory storage. Of course, it is legacy, but still we need this functioning, at least for the tests. So it's going to be find by token. And we are providing a token here. Then token, please. Else token. It should be equals token. Right, so that was fairly easy. This one is going to be just a bit more complicated. So find user by token again. So we take in token. That is string, that's all right. Find user statement, we need to change this to another statement. Find user by token statement, that's all right. And now we see that we don't store token in our schema, so we need to update schema. So our token equals this. So where is the create table schema? Here it is. User, last name, role, and then we are saving our token. And our token is going to be text. That does look good to me. But we also need to change, we need to change update user statement. And actually, let it be, where is the update, self-update statement, username, user ID. Here we need to provide our token. Yes. Looks okay. I'm not quite sure if I had broken anything, but let's see. At least one test should break at this point. And this test, if I can find it fairly quickly, here it is. So this test to create and retrieve user should fail now because we are not providing the token here. We can't provide a token here. So this should fail, and that is indeed failing, raising the correct exception. So that's a good sign. That's a good sign. Let's move on. After updating tests, at least those tests which make sense to update now, we have propagated the functionality for authentication to the API. We have changed our endpoint configuration. Now it tries to find authorization header, and if authorization header is found, it is propagating this to the user controller. So the changes to the endpoint configuration were minimal. The only thing which has actually changed here is that I have started propagating exception like this. But what I can do instead is probably try to add some generic logic for handling exceptions. But that's exercise that I would suggest you doing. By the way, if you know how to do this, feel free to write in comments. Now going to the user controller, which had a bit more changes, but still not much. Now we just take an authorization header. Authorization header is usually comes in a format bearer and then token. That's why first we are removing bearer from the string, and we have only token here. And then when we have token, we propagate this token to the user service, so user service can do whatever it thinks is necessary to do with the token. At the same time, there is a bit of error handling here. We are checking authorization header for none, because if it's none, there is nothing we can do. And let's see now how it works with the real API. First, we are creating a new user. Then we are authenticating our user and we get authentication token. Then we try to get data for the user providing the proper authorization header. And everything just works. On the other hand, if I try to get the data for the user without authorization token, I get this message. Our next logical step would be to add the functionality of the authentication to the update and delete, but actually it is done already. See what's happening here. Both update and delete are calling get internally. So what we need to do is just pass the token that we get in those methods. Done. And now they magically have the authentication logic. The only thing is that I think that authorization verification is rather cumbersome and probably generic logic, so I have taken this into a separate method which does nothing but authorization. And in our case, because both update and delete depend on the get method, it will just work by magic. But if it weren't the case, I could have reused this authorization verification method instead. And as your first home assignment for the authentication verification lesson, I would suggest you to propagate update and delete functionality to the API level. Update and delete authentication and authorization functionality in this case. And how we are going to add administrator user? Well, what we can do, because we can't create administrator user using API, we can add a hard-coded or rather configured user token for administrator in some configuration file. And actually the whole administrator user workflow is almost identical to the typical user workflow, and I'm suggesting you to do this yourself so you will remember the course material better. And that was everything. Now it's time to wrap it up and see what we have learned in this whole course. There is a 3-layer pattern, which is a very common pattern for writing web application and web APIs. And the big idea is to put as much business logic into business layer and as little logic into input and output layers. And let's see how we actually did, how it worked for us. So presentation layer have just 2 files, in our case, user controller, which is mapping the HTTP terms to the user API terms, and main py, which is essentially containing the Flask configuration. Then we have the most important layer, which is a business layer, and it has obviously the more code than anything else. First, we have the model, which contains role and user object definition. Then we have user service, which has most of the logic, and there is also user validator and exceptions. And finally, we have tests, which are verifying the business logic of our application. And in the persistence layer, we just have an interface for the storage, and we have some implementation for this interface, which is in memory and SQLite storage. And just a small advertisement here. If you want to support my channel, you can do this by buying this very course on Udemy or Leanpa platforms. And in addition that you will get here would be some quizzes and additional home assignments, so you can learn the course better. And obviously you're going to get a completion certificate as well. But the course content is the very same, so if you don't want to spend any money, you don't have to. And that was Alexander Pushkarev. Thank you very much for joining me on this masterclass on software architecture patterns. And I would like to suggest you subscribing to my YouTube channel, and that is my YouTube channel handler. There are going to be lots of useful tutorials and videos on software design, software architecture, artificial intelligence, and test automation. So if you're interested, don't forget to subscribe and hit the notification bell.